Okay. We can see your screen now, Mitch, and I think we should be all set. And I will post the call-in info in the chat again, just in case folks didn't see it. So thank you again, everyone, for joining us today. This is Christine McHugh from the regional office. And thank you for joining us on our second Saltmarsh Sparrow webinar. Today, we are going to be covering the habitat patch prioritization tool that's been developed by the Atlantic Coast Joint Venture. And Mitch will be our presenter today. And just please remember to mute your phones as you get logged into the audio. Mitch, I'll hand it over to you.
Okay, thanks, Christine. And I would encourage people, if they have a question, it's kind of different for all of us to do webinars. No one's in the room together. If people have questions and they can chat it, maybe, Christine, you can monitor that and jump on or let me know, or free to stop me. This is pretty casual, and I don't mind being interrupted, so, you know, whatever makes sense. But I would say go through Christine so she can regulate it. But I'll jump in. My name is Mitch Hartley. I'm with the Atlantic Coast Venture. Can you hear me okay, Christine and everyone?
Yep.
Okay. So today I'm going to talk about a Saltmarsh Sparrow habitat patch prioritization tool that's been developed by our staff and partners over the last couple of years. You can find that on our website, acjv.org. The actual link to the online tool is up there, which of course you can get to through our website. And let's advance the slides. Hold on. So I'm first just going to give a little bit of context for the tool. For most of you, this will probably be pretty familiar, but Saltmarsh Sparrow is restricted to salt marsh. It's the only native bird that's entirely restricted to breeding in the northeastern U.S. And it's not just restricted to salt marsh. It's, for nesting habitat, it's actually restricted to high marsh portions of salt marshes. And it's experienced a very serious population decline since 1998, about an 87% population loss, 9% declines, and that's a steeper rate of decline than just about any bird species, you know, that we know of, certainly for a long time. Its main threat is basically low activity due to nest flooding because of a combination of increased sea level rise and marsh conditions. We'll talk a little bit more about. But the bottom line is we really need to improve its habitat quality and the resilience of salt marshes, you know, that hold that habitat, both sort of at a couple different scales, and I'm going to talk a little bit more about that too. High marsh has been declining for some time across the region, and there's lots of different studies from different decades that show this change. To some extent, it's been going on for like 100 years. Again, partly through changes to salt marshes by humans, and more recently because of sea level rise. But some of the widespread changes are a transition from high marsh to more conditions, more frequently flooded marshes. Typically where these birds were nesting historically, they were not very frequently flooded, really just on spring tides usually, once or twice a month. And now they're getting flooded very frequently, and that's changing the vegetation, probably on a slower timeline than it's changing the birds' breeding dynamics, but it's still changing the marshes. And because of this combination of sea level rise and historic changes to marshes, we're seeing increasing ponding or waterlogging of marshes. And so there's just more water on the marsh more of the time, and that's causing more open water and die-offs of vegetation. And as I said, this transition to low marsh conditions in some cases. So really there's two things going on at the same time. The habitat quality for Saltmarsh sparrows is clearly decreasing, but also the resiliency of these marshes overall and the high marsh habitat ecosystem, or that portion of the ecosystem, is also declining. So we really need to attack this in a couple different ways, but to sustain this population, to recover it and keep it into the future, we really need to be thinking on several different time frames over sort of a short term, a medium term, and a long term. In the short term, we need to immediately start working to improve the quality of current salt marsh habitat that's supporting these birds so that they can have some improvement in nest success, or if they continue to have large spread reproductive failure, obviously they're not going to be around for much longer if they're not producing. We also, though, need to be thinking about a longer time frame, both a kind of medium decade or so long time frame, and then a longer one of really, how are we going to sustain these birds over the next century? And really, one big aspect of that is providing for future marsh migration. As sea level continues to rise, we will be able to offset some of the loss of salt marsh by migrating marshes inland, and that's happening in some places and can happen and should happen, but it doesn't mean we don't have any role in that process. And the main thing is for marsh migration to happen, we have to understand what areas are suitable for marsh migration, because lots of places aren't suitable because of topography or whatnot. And we have to protect those areas from development. And that's really critically important, because if you think about it, some of these marshes are not going to be suitable as habitat for decades. And so every single year between now and that gradual process of marsh transition is a window of time where that can be developed. And as you can see from the lower picture and kind of imagine, where we have any degree of development, but certainly, expensive homes or extensive development around salt marshes, it's really unlikely that we're going to be able to have any salt marsh migration in those places. So we have to identify those places where the topography is going to allow migration, there's not development, and we can keep the development out from land protection. And then I'm not going to talk about it today, but we also may need to facilitate marsh migration with management to some degree. Kind of the simplest example of that is treating Phragmites in areas that are transitioning to salt marsh, where it might migrate faster and become high-quality habitat if we don't let Phragmites take over. Phragmites dominated, that may really slow or even prevent it from becoming salt marsh in the future. So today I'm going to talk about our tools, and our tools actually include data that address both the short and long-term issues. The first thing, which I'm going to mostly talk about, is our habitat patch prioritization tool, which has both a regional perspective and a state-specific version. And then also, we on the same website, we have the marsh migration space, which is not our data and our model. We're just mirroring the data that's been produced by TNC, which some of you are probably pretty familiar with. And they have a good product that people have been using and liking, and a lot of people help them develop it and buy into it. So there was no need to recreate that wheel. We're just using the data that they've provided. So I'm mostly going to talk about this first version, which is our patch prioritization tool. And I know this is kind of a complicated figure, but this is just the conceptual diagram, which is where we started with the model. So we looked at the factors that influence Saltmarsh sparrow populations, and the ones in green boxes are negative factors that are hurting them. The ones in green, the ones in red are negative factors. The ones in green are positive factors. And then this was just starting with a blank slate, saying, well, what's affecting things? And then we looked at this influence diagram and said, well, what do we actually have data that we could model? So the boxes that have the orange borders around them are the factors that we actually, variables across the bird's range that we could incorporate into a habitat prioritization model. And that boils down to just these 7 factors. The ones in green, again, being positive, the ones in red being negative factors. So those are the factors that we can actually model and, that we have the data to use. And then we went out to the experts that were helping us develop this and said, well, are some of these factors more important than others? And if so, should we be giving them some weight? And people agreed that, yes, some of these factors are more important and we should be weighting them. So we did an expert elicitation to assign weights to each factor so that some factors are given more value in the model and others are given a smaller value in the model. And those weights look like this. The number 1 variables on the positive and negative side, respectively, are high marsh area and the probability that it's going to be inundated in 2030 and 2080. It's actually a combination of those two, the probability of both. The amount of marsh that's in the sort of surrounding buffering landscape, as another positive factor, and the actual resiliency of the landscape, which again is actually just based on TNC's resiliency scores in the TNC coastal resiliency data set. On the negative side, the second biggest factor is tidal restriction, and that's a data layer that came from the North Atlantic LCC, which really just looks at how severely tidal restrictions affect an area. And I won't go into that more, but that's a data layer that people can get through Databasin and learn more about. The proportion of the patch that's in Phragmites currently, and the probability of development in the landscape. And you can see those last couple have a fairly small weight in the model. One quick point I want to make is that both of those first two positive factors, high marsh area and marsh buffer, when you look across the whole universe of nearly 9,000 salt marsh patches that we have in our model, both of those variables are very, very highly correlated with the patch size. And so while patch size is not in our model, it might as well be, because these variables are, greater than 90% correlated with patch size. And so I just want to be clear about that, this is a fairly crude model in that it's driven, number one, by just how big is the patch. That's the number one thing. And if that's, too unsophisticated for you, then that's fine. We just want to be transparent about what this is and what this isn't. And those are the factors, because they combine to be about, greater than a third of the overall weight, is basically just patch size. And then second to that would be the inundation probability. And then kind of tied for third would be degree of tidal restriction and the resiliency of the landscape. And one thing I'm going to talk a bit more about, but I want to point out here while we're looking at the 7 factors that are in the patch prioritization model, that there's not any actual bird data being modeled here. So this is strictly a model of habitat patch characteristics and which ones we think are most important for birds. And I'll say a bit more about this, but I think people often assume that this is a model driven by bird data, and it's not. So it's really important to emphasize that. So we combine these factors by first ranking each of the factors from the very best conditions to getting the lowest rank, like the number 1 patch, and then the worst conditions would get the highest rank of like the last patch, number 8,600 or whatever out of the total. So each one of those was ranked, transformed individually, and then we combine those ranks with the weight that I showed you to come up with an overall rank for every single patch, from the best patch in the region to the worst patch in the region. And those are, if you look on the model, on the maps, those are put into 10 bins, sort of darkest to lightest with the best conditions, the top 10% of the patches, and so on. Again, I just want to reiterate, this is not a model that was informed by the data that are out there for Saltmarsh Sparrow. And many of you are probably familiar with some of the published work that came up with the population estimate for Saltmarsh Sparrow. The Weiss et al. Paper, there's actually been a couple papers that use these data, and they did extrapolate densities across all the patches in the region. And when we first started this endeavor, we thought this was going to be really easy. We were just going to kind of put the map of their model up, and serve it up to people and say, hey, here's how many Saltmarsh sparrows we think are in each patch. So the patches that have big numbers are good patches, and the patches that have little numbers are not so good patches. But in talking to those folks, clearly that was not the purpose of their research and their paper. They were trying to extrapolate across patches to come up with a robust density estimate for the global population, but they did not consider those numbers to be predictive of what would actually be expected in a patch, and there would be probably really large error rates around those predictions if we consider them as predictions. So keep in mind that those errors that we would assume would wash out across 9,000 patches, but wouldn't necessarily be something that would be palatable on a patch-by-patch basis. So we have included the SHARP data, the survey count data for Saltmarsh sparrows as a layer of information, so that where it exists, you can see it, and that can be helpful perhaps. But we want to be clear that that the model here is not is not based on that data. It is based on some of the same physical patch factors that they used in their model, but not the actual bird data. And this is a page from a map that was put together by Audubon in Maryland that we're using as our template. Basically, we're trying to replicate this for each of the states, and this will be in our Saltmarsh Sparrow plan and also be on the online web tool. But the hexagons are the areas that were selected at random to be surveyed, and within those hexagons there are points. And then based on the size and color of the points, you can see the average count at those points. So the dots that are in black, were zeros. They were counted, but they found no birds. And then the colored and larger dots had larger abundances of birds. And so, you can see here a couple of important things. First of all, you can see what was surveyed and what wasn't. So if you're interested in some patches and they weren't surveyed, there's no data there, and that should give you some sense of why we wouldn't want to just use the extrapolated patch numbers for that part of your part of the. Can you still hear me?
Now we can. We lost you for a bit.
Oh, sorry. I don't know what happened. Okay. So do I need to repeat anything? I was talking about this map.
Mitch, you were about halfway through that map when you went out.
Okay. So basically, we're mapping the sharp data that are out there so that people can see it and potentially use it. And this shows you a couple useful things, basically what areas within your state were surveyed and which ones weren't. And where they were surveyed, you can see, which areas had more or fewer birds. So this could be helpful depending on where you are and where surveys happened. But I'll move on. So I mentioned before that this is actually a screenshot from the online tool for the patch prioritization. And the first tab that you see up there on the upper left says Saltmarsh Prioritization Mapper. That's the ranks of all the patches for the entire region. And it shows you the regional rank. So the patch that's selected, which is kind of in the upper right, circled in light blue, that patch is number 607 out of 8,700. So it's a pretty high patch. That's the regional rank. But then if you click on the State Priorities tab, the next tab over, you see each state has its own prioritization. And if you click on a state, in this case New York, and then you click on a patch like this patch on Long Island, it shows you the state rank. So this particular patch that's selected was number 6 out of the 1,200 patches in New York. We were assuming that these state-by-state prioritizations are probably what partners will mostly be using, because that's the scale people are working at, not typically comparing patches across the whole region. And then I'm going to switch over. So this is the second data layer on the tool, which is the marsh migration space. And as I mentioned, this is simply data that TNC has put out there, and we've used it. Here we're combining the sea level rise resilience score for 3-foot sea level rise and 6-foot sea level rise, and that highlights these patches. And the way they scored them was average, above average, slightly above average, and far above average, and then the others are below average. And on this layer that we have actually also the protected lands database. So you can toggle that screen off and on and see if you're looking at these marsh migration corridors, you can actually see what's already been protected and what isn't. And in some cases, you'll see these big blobs of marsh migration space and think, wow, that's a really, looks like a really important target. And it may already be all protected. And you say, oh, okay, great. And others, of course, could be the opposite. It could be a really juicy looking target, and you look at it and yeah, none of it's protected right now. So that should really help prioritize land protection in these areas. And that's the end of the formal presentation. I was going to now do a little demo of the tool, and I'm gonna change screens and see if anyone. I'll just ask if you want a particular anything in particular of the demo, or like a particular area. We can do that. And so this is the actual tool now. Can you guys see that on the screen? Christine,
yep.
Amy? Okay, making sure I'm not talking to myself again. So this first tab, as I said, is the regional prioritization. And a couple things to point out here. So this just gives you, there's nothing here except on this particular one except for the ranks, but I'm going to zoom in a little bit to Delaware Bay. And you see, of course, Delaware Bay has very large tidal marsh complexes, and you might think that this is all one patch because it's all the same color, which is the best class. But if you click on an individual polygon, and unfortunately this puts the thing right on top of it, but you can see that this is not one big patch. It's actually, made up of discrete patches that, each have their own individual rank. But in this particular case, because they're all the same color, they're all fairly similar in rank. They're all in the top 10%. But that, I just wanted to point that out. And then if you click up here at the above where you're looking here, there are other data layers you can bring in, which are important. And I should have mentioned this earlier, but you're able to map each of the individual factors that are in the model. And so this is important, I think, for people to kind of see have the transparency to the model of if a patch ranks really high or really low, and you might be confused. You might think, wow, I thought that was a good patch. Why is it in the top 10%, or why is it ranking so low? And you can actually toggle on for these particular layers like sea level rise, and this, which is what I just clicked on. This is showing you sea level rise for of what's going to be inundated. The probability of inundation is an important driver in the model, and this is basically showing you what's going to be inundated, and that's a big driver of the patch value, the actual rank. And this is marsh migration space, which gets a very small amount of weight in the model, but that's sort of the site resiliency. This is the tidal restriction layer, which talks about how the degree that the area is tidally restricted. And so what you can see here, so this does really well, the tidal restriction. I'll go back to the legend. This has very low influence of tidal restriction. And of course, this particular parcel, it's not surprising. It's right on the bay. And these actual black dots represent a point layer of actual tidal restrictions. And so it's pretty obvious at this scale. You can see these marsh complexes have no degree of tidal restriction below these points, and then above that, they have a very high degree of tidal restriction. And in all likelihood, those red patches are not salt marsh. They're either uplands, or they're freshwater marsh, or there's something other than salt marsh in many cases. So that's how you can look at these individual layers that made up the model. There's some other data layers here like topography and aerial imagery. This is just some context here for details. I'll pause there for a second. Does anyone have any questions about the overall regional one? Because I'm going to switch now to the state priority one. Just to keep things consistent, I'm going to stay in New Jersey.
This is Jean. Can I ask a question on the, you said that you could look at protected areas. Can you also look at the amount of land use changes, development or agriculture, et cetera?
Land use changes. No, I wouldn't say we've incorporated that in any way. Kirsten can maybe jump in. Some of these base layers may have, let me go back to this base map. some of these base map layers could have land use. I'm not really sure, Gene. That's a good question.
It was just a question of that migration and barriers.
Yeah. Well, certainly the TNC data, a big driver of that is land use. So to some extent, that's baked into their model of what this map. So I switched over to the Marsh Migration Space tab. I'll go back to New Jersey. So here's Marsh Migration Space in New Jersey. And the big driver of these scores, looking back, hold on. Oh, okay, these toggle on automatically, I guess, sorry. So here the Marsh Migration Space comes on automatically, both for 3 foot and 6 foot, and you can toggle between them if you want. And then you can overlay on that. I'm going to zoom in a bit. One more time. Oh, frozen up a little bit. So here you can toggle on the protected areas database. Zoom in. Try to zoom in one more time. It's kind of hung up on me here. Huh. So you can look at the actual patches, the ranked patches, or not. If you know they're generally not overlapping with that space because these are migration spaces, not marsh spaces. But here's the protected area layer, and there we go. So let's look at this. So this base layer here is actually showing some protected lands, but when we toggle this on, those should light up. And you could look at the legend to see where is the legend. So this is showing you the ownership from that PADIS map, Protected Area Database of the U.S. It's just showing you who owns what. And if we take these off, like here's a good example where you've got a lot of protected land overlapping with the marsh migration space. And we can, presumably we can change the transparency of these. I'm not sure if you all can control that or not, but you know, you can see where these things overlap the protected lands and where they don't. So again, the TNC layers definitely look at land use as a major driver of whether or not its migration, it's suitable as marsh migration space or not. So there's a lot of that built into their model, but we're not really addressing it here. I'll just say really quickly, these last few tabs while I'm demoing it, this just shows you some of the stuff I've shown you in the presentation, like the conceptual model, the actual variables and like where they came from, and then this is the factor weight. So this is all, these 3 tabs are just context and explanation, which I've tried to cover here. So these first 3 tabs up at the top are the real tools that you'd be using. So I'm going to go back to state priorities here, and we'll contrast. We'll take a look at a different state in a different part of the range where the marshes are smaller, more isolated, like coastal Connecticut. So here, I'll bring the legend back up. Oh, I guess I'm not seeing the legend. Oh, I have to click on this, I think, to, there you go. If you click on each one, it shows you the legend for that variable. So I'll pause there. Amy or Kirsten, were there things that I was going to demo that I've already forgotten about? Probably.
There's been several people in the chat that have asked for certain things. I think there was someone who asked to look at like Cecil County, Maryland, that area.
All right, well, I'll go to Maryland. I don't know where that county is, so can anyone here's Maryland. And if you're wondering why the western half of Chesapeake Bay, Virginia and Maryland portions of the bay are not included in the model, it's for a couple of reasons. And I'm wondering if that county might be over here, because I think I know the names of these counties. And that is because Saltmarsh Sparrow doesn't get, its range doesn't really extend north of where the model is here. The bay is too fresh water, so the birds aren't up there. And there are some birds, I think small numbers of birds over on the Virginia side of Chesapeake Bay, but the high marsh, low marsh vegetation mapping that was done by the North Atlantic LCC and done by the Sharp folks, it didn't include the western portion of Chesapeake Bay because I think primarily because there are no sharp marsh, very few saltmarsh sparrows over there. So it's not a perfect model in the sense that it doesn't necessarily include every single patch of saltmarsh that could have a saltmarsh sparrow. And certainly in the future, some of these, the distribution could be shifting with sea level rise and as salinity changes in the bay. But we've cut the model off here where the saltmarsh sparrow distribution ends. And we did the same thing, I should just say, up here in Delaware Bay. But we're not looking at Delaware. We're looking at Maryland, so it's not showing it. So here's Delaware. We've cut the model off where saltmarsh sparrow range basically, their current breeding range basically ends.
Yeah, this is Dave. I was the one who popped in that question about Cecil. Yeah, I was just, you hit it. I was wondering what was going on north of Blackwater National Wildlife Refuge up to all the way up the eastern shore there.
Okay.
That's where I know there's sightings. I know there's sightings either side of the Chester at Eastern Neck as well as around Kent Island.
Okay, that's up here where my cursor is?
Yep, you got it. Yeah.
Yeah, one thing go ahead.
I was going to ask a different question from the chat, so if you were going to finish that, go ahead.
Well, one thing I was going to point out, which I meant to, is when you're zooming into these patches, and I think this is true at the state level, but I'm not seeing tidal marsh data is in the state. So if you are looking at either the regional or the state level, and you're interested in a particular patch, let's say this patch here, if you zoom in far enough down, you see this data on the tab that says tidal marsh data. If you're zoomed in to a high enough resolution, which I'm still not, that toggles on, and you can actually see high marsh data. So I took the patch layer off, and this is actually getting at whether it's high marsh, low marsh, mudflat, phragmites, and this is from that high marsh, low marsh veg data that I mentioned that was done by the North Atlantic LCC Sharp Book some years ago. I think it came out in 2018. This actually gets down deep, and you can see here in this particular patch, although this patch is ranked high, there's not a whole lot of high marsh that's showing up in this. And so this is a way of comparing patches at a more granular level, seeing the underlying veg data. But for this to display, because as you can see, this is a really data-rich layer. And if we were trying to load this up at higher resolutions, I think it either wouldn't show because it's granular, or it would take forever to load. And I'm not sure which or both, but that's why we have to zoom in to see it. So Amy, go ahead and ask a question if you have one.
Oh, Mitch, sorry, before you do that, just a quick reminder, I did turn off the mute all option since we're getting to questions, but if you could just make sure that your phone is muted, we are getting a little bit of like background feedback.
Perfect. All right, Mitch, one of the questions, when you say a patch has a rank, is that a rank for short-term projects such as thin layering or long-term such as land conservation?
That's an excellent question. So these two tools, the marsh migration space for land protection and the patch prioritization, we're really seeing them as very distinctive. So not that you wouldn't ever consider land protection around a patch, because certainly you would. It's important, and I should have mentioned this before, it's pretty important that these patches are buffered with protected lands for a variety of reasons, including, just better land use next to a patch is going to mean not just higher probability of migration, but less disturbance and runoff and issues like that. There's plenty of evidence that salt marsh birds in general do better in patches that are not next to development than patches that are patches that do have a lot of development. And there's other issues like shoreline hardening that have to do with marsh resiliency that are pretty important too. So considering a patch's status when you're doing land protection is certainly important, but we really we're thinking of these as pretty discretely different. So for land protection, we were mostly highlighting that marsh migration zone and focusing on that. And the ranking of patches is really more, like you said, for things like thin layering and improving current conditions and current habitat quality, or habitat quality over the next, say 5 to 20 years. That's really what we're thinking of the rank as. But, reasonable people could maybe disagree about the timeline of that and how, what timeline we should be working on. But that's basically what I think the consensus was the rank indicates how important we think the patch is right now to do, targeted restoration type activities, and consider protecting the immediate buffer and not just the marsh migration space. And one other just related point to that, that's a question that often comes up in discussion is how important is it that we tie the marsh migration space to the existing patches? And that's a really good question that we've talked about a lot. And the current thinking on that is that we don't really think we need to consider these things as tethered to each other in any meaningful way, because the salt marsh birds, they disperse widely. Saltmarsh sparrow, it's traveling throughout, the northern birds are traveling through this fairly contiguous salt marshes. They're moving south into their wintering areas. And so they're sort of aware of where the salt marshes patches are on the landscape when they're dispersing and returning to breed and so on. And this marsh migration process and these future marshes that we want to provide for, those are going to take decades to develop, and that represents generations of salt marsh sparrows. So our thinking is that some of the current patches that could be really good today are probably going to be underwater and unavailable in future decades. And these other marshes that we're going to try to sustain into the future and allow the creation of, that could be 50 years from now. And when that marsh is, if we're successful and that transitions to a nice high marsh and is occupied by salt marsh sparrows, it'll probably be occupied, regardless of what patches used to be nearby and how nearby they were. And so, this is it's a little bit theoretical and speculative when you're looking into a century time scale and talking about bird distributions. But our thinking is that it's not important that if you have a future marsh migration target that you think is important, its proximity to a currently important patch we think is probably not very significant at all. And again, some people might disagree with that, but that's what we've sort of come up with overall, is the general sense.
There was another question on the chat about, can we show
all the patches just in order of rank. I think that was the gist of the question. And at this point, instead of clicking through them, and at this point we can't, but I'm going to make the data available to download for those with GIS that they can, download and explore the data. At the moment, it's I need to create some metadata so that when we're sharing it out, the main data set, when I'm sharing it out, it's all clean and makes sense, because at the moment there's some stuff in there that's included from some older work that we were doing. So I need to clean it up, but I can make that available.
Yeah, and one of the things I meant to do is just show you the data that comes up when you click on a patch, and this is back to the overall patch model for the region. And I was thinking it had like a patch ID in here, but I don't think it does. Is that correct, Kirsten?
I'm sorry, ask the question again.
When you click on a polygon and you're looking at these attributes, it doesn't actually have the patch ID showing, right? It has the rank, size, and then the values, the actual rank of each of the values, the factors that went into it, but doesn't actually identify that unique patch, right?
Huh.
You mean the rank out of the total, Mitch?
No, I mean like
you're right. It isn't
polygon ID.
The actual polygon ID, I've pulled that out for some reason. I need to just check a box, and I can have that show up as like the pop-up title. Yes, I can put that back in there.
Well, I was just thinking out loud, but when we want to look at individual patches, the actual data set here, it's only 7 variables, the combined ranks. 9,000 patches sounds like a lot probably, but all the data that's in this model for the patch prioritization is fits on one Excel sheet, and it's not that hard to navigate around and see, rank patches by each of these, so if you look at this box that I clicked on, this is overall in the top third of New Jersey. You see it's ranked very low for size. It's quite low ranked regionally. These are the regional ranks, I guess. It's ranked quite low for inundation, meaning it has a very high probability of inundation, but it ranked really high for things like how much marsh is around it, how much high marsh is in it. It ranked well for development. So these are the things that are driving it. It ranked well for TNC resiliency and high marsh. I guess that's already up here. So you can see what was driving its rank. But we often play around with that Excel sheet, and then we'll go out and look at an individual. If we see if you want to know what's the number one patch in my state for anything overall or for each of these variables or whatever, it's easy to do that in the Excel spreadsheet, and then that sheet has the patch ID, and then we can identify that patch pretty quickly. So it sounds like we can put that patch ID back in here pretty easily, and then if we make the Excel sheet available, everyone, and it's a very small file. It's easy to download it's a tiny little file that has all this data on it for the 9,000 patches. I think it sounds like, Kirsten, that's easy to do, right?
Yes, that's easy to do. I'm sorry. I need to hop off.
Okay. I can't see the chat screen for some reason yet, maybe because I have too many screens open, but are there other chat questions? Christine or Amy?
There's one. Yeah, so we already talked about showing the rank order, and then the next question was, for all of the rank values, is a lower value better?
Yes. Yep. A lower, and that's true for the factors, and that's true for the rank. So, for example, probability of inundation. If the patch that has the highest probability of inundation of all the patches, that doesn't get a high rank. It gets a really low rank. It would be the worst. The highest probability of inundation would be the worst conditions. So that would be like ranked 8,160 out of 8,160. And the patch that has the absolute lowest probability of inundation would be ranked number 1. And so whether it's a positive or negative factor, if it has a rank closer to 1, it means it's the best possible set of conditions, whether that's high marsh area or probability of development or whatnot. It's always ranked from best conditions to worst, if that makes sense. And then the overall rank reflects that as well. What we think would be the best patch to work in versus the worst patch. And, worst, it could be rated worse for a number of reasons. But the reason we talked about it initially when we developed this is we thought, patches that have a very high probability of inundation are patches that some people just aren't going to want to work in because they're predicted to be underwater relatively soon. Now, of course, if you're doing things to improve the resilience of that marsh and try to increase accretion, it might be really worthwhile to work there. But if it's predicted to be, 3 feet underwater in 10 years, that might be someplace that you just decide it's not worth it, too risky. You don't want to invest there. And that's something, that partners are going to have to make those decisions kind of individually on the ground. Those aren't easy decisions to make in a decision support model or anything. Other questions?
There are not any more questions in the chat window.
Okay, well, I would just encourage people, if you have more technical questions and you want to talk to us one-on-one, you can certainly email or call Amy Weldon or me, Mitch Hartley, or Kirsten Luke, and any of the three of us could help you and either provide data or tell you more about the data or tell you where to find the data and so on, point you to the right sources, pretty easily, I think. So I would, don't hesitate to reach out to us if you have questions about this.
Yeah, Mitch, there were several questions earlier about sources and stuff, but Kirsten was all over that, posting the links to the sources. So I am going to, this is being recorded, but I'll also save the chat questions and window with those links, and we can provide that as a follow-up with the links to the source data that Kirsten had mentioned earlier.
Yeah, and I'll point out, certainly for the TNC data, you can get to that stuff here. We, of course, since we're just serving up their data on this tab, we're providing the links to that data right here on the page. And some of these other, we don't necessarily have that same level of how to get each one of these data. But certainly I think almost all of these data, if not all of these data, are available on Databasin, and several of the main layers come from North Atlantic LCC data layers that they, were responsible for getting or, paid for or whatever. So Databasin is probably a source where all these data are available. I say probably because I'm not 100% sure about every single one, like that development probability. I'm not quite sure where that layer came from. But certainly Kirsten could point anyone in the right direction easily enough.
Yeah, so Bree asked if you can download the prioritization layer yet off of the site.
I don't think so. I don't think you can download data off this site yet. Amy, if you know otherwise, definitely jump in. But
I'm here. Yes, I think someone who's savvy with ArcGIS Online could find the data layer because it is available to grab and download. But I'll make it more obvious. Like I said earlier, I just need to clean a few things up because there's some relic information in the main data set.
Yeah. And I think certainly we've talked with many of the Maine and New Hampshire partners about this before, but it's probably worth noting that this is based on the SHARP data that's available for download on the SHARP website, and there have been some issues identified for this part of the world where there are a number of Nelson sparrows and hybrid birds there are some issues with the counts where some of the birds that were counted were counted as hybrid, not as Saltmarsh sparrows. And so the Saltmarsh sparrow numbers that you'd see in this part of the world, when you're displaying the SHARP data, will, there's questions, there's issues with those counts and whether they're, maybe biased low or something like that. And we're looking into that, but I will just remind people that the actual patch prioritization is all based on physical patch characteristics anyways, not on any bird data. So, even though we will try to deal with that issue one way or the other, that will only relate to when we're overlaying the actual bird data, which we don't have mapped here yet. We're still working on those state level maps of the SHARP data that I showed you, the Maryland example with the finished product. Oh yeah, unknown sharp-tailed sparrow, that's right. That's what I meant to say. I just saw that chat. Some of these chats are popping up on my screen, but I don't know where they're coming from. So, but yeah, they were, some of the birds were recorded as unknown sharp-tailed sparrow, and some of those then didn't get counted as Saltmarsh sparrow. They got counted as unknowns. And so if, depending on the year and the observers, if you had lots of birds that were counted as an unknown sharp-tailed sparrow, that could have messed with the numbers a little bit. But I think most of the partners in Maine and New Hampshire are aware of that. And I think generally people know where the birds are there anyway. And so I'm not sure how much that's hindering conservation efforts, but certainly it's something we've been talking to them about for a while now. Other questions or comments?
Chris just confirmed that it was unknown sharp-tailed, which you were already just saying. And we can confirm the availability of the layers on Databasin in the follow-up to the webinar with links. And then Chris Elphick just said it wouldn't be hard to find a way to assign those birds, for example, if we assume the ratio for identified birds is true for unidentified.
Right, yeah, that's what we've talked about. I think it would be a fairly easy thing for people to deal with. We just haven't kind of all gotten to it yet.
Yeah, I think those are the only questions. Oh, and Mo said we recently used a model to do that for unknown grassland sparrows. So those are all of the questions. And since we only have a couple of minutes left, first of all, I just want to thank everyone for joining us today and for joining us on hopefully the next Saltmarsh Sparrow webinar, which will be next week. So I was just going to pop up the invite for that. So we will be hosting another webinar next Thursday on May 14th from same time, 11 to 12, about farmers in the marsh. And Sue Adamovich will be facilitating that webinar. So if you don't already have that on your calendar, please add it to your calendar, and we will send out an invite via through the programs to remind everyone about that. So mark your calendars and invite to follow. And if there's any final questions, otherwise, thank you all for joining us.
Thanks, Christine.